Sure. I'm Professor Emeritus at the University of Arizona. I am a conservation biologist. I received my PhD in 1987, did a postdoc at the University of Georgia at the Institute of Ecology, and then my first academic position was as a visiting assistant professor at Texas A&M University. I was 20 years in active service at the University of Arizona as a conservation biologist, and I became emeritus professor there in 2009, May of 2009. So
right.
I've been studying climate change since I was in graduate school in the early 1980s.
Early 80s, okay.
So my interest in the connection between climate change and life on Earth goes back more than 30 years now. You know, conservation biology is a discipline or an enterprise that focuses on connecting the dots.
Right.
So it's not an engineering endeavor that tends to focus tightly on one particular aspect of a system. Conservation biologists tend to be quite multidisciplinary, transdisciplinary, interested in a wide variety of factors.
Right.
And that's well suited to the work I've been doing for the last several years.
Okay. That's one reason why I wanted to interview you, is because there are a lot of scientists that are very specialized in what they study. And so you learn about some particular aspect of global warming and its effects in an area, but getting the larger picture of how that's going to impact, first of all, other areas, but also how it's going to impact humans. Sometimes that picture is missed.
Absolutely. In fact, many climate scientists, including the most famous of them, James Hansen, for example, have degrees in astronomy and physics. So no understanding of or appreciation for the living planet, for the complexity of life, and beyond that to ecology and the interactions between plants and soils, plants and animals, and the atmosphere, the environment in which those organisms are embedded. So that's frequently missed by climate scientists who tend to not know how each species is stunningly well suited for a particular environment and has evolved through natural selection to a particular environment. So you change something a little bit, whether it's the temperature regime or the precipitation regime, you change it, or the soils on that system, and in all likelihood a species is not going to persist in that system anymore because you change that one thing a little bit.
So then the question is whether it can survive by migrating to some degree, and if it can't, then essentially it's not going to be able to survive.
And because so many species are codependent upon many other organisms, that idea of picking up and moving somewhere probably is not going to work for most species. Certainly not for long-lived species like trees that tend to be sessile. And a tree can't get up and take its mycorrhizae and its fungi with it and move 100 miles up north.
No, it'd be quite a strenuous effort for it.
And staying where they are in light of a overheated planet with a rapidly changing precipitation regime isn't going to work either. Because those organisms evolved for that place over tens of thousands, in some cases millions of years. And it's a delicate web that these organisms are embedded within. And so, you can't just throw all kinds of environmental change at an area and expect those species to persist, or other species just move in and say, hey, this is my kind of place. It just doesn't work that way.
Now, you used a word there that I had mentioned to you in some of our correspondence about overheating. And I think we talked a little bit about this as far as the terms global warming and climate change being somewhat euphemisms. Effectively, the problem is that we're overheating the planet in general, and that's going to destroy habitat and environmental systems.
Exactly, and habitat is key here, and something that I think is, for the most part, largely misunderstood, or probably more likely people are just ignorant about it. The place where an organism typically lives and grows is a simple definition for habitat, but it's not easy to understand because we walk through our daily lives and we see the grass growing out there. Oh wait, doesn't really belong there. It's
Right.
only maintained as a lawn because we do a bunch of things to change the habitat.
Exactly.
And then we see humans everywhere. We see humans in the International Space Station. We read about humans in nuclear submarines. Humans go to Antarctica and survive. There's just a couple of stations down there that are housing humans right now. And so people think, well, if we can live in those kinds of extreme conditions, surely we can create our own habitat everywhere. But in fact, the International Space Station, McMurdo Station in Antarctica, and nuclear submarines, they aren't habitat. All that food comes from someplace else.
Right.
And so that's important to keep in mind, that the conditions required to allow people to live in those places aren't found in those places.
So when those other places are destroyed by way of overheating and other changes to their environment, then of course those remote places will not be able to survive as well.
Exactly.
Yeah.
So we won't have people on the International Space Station if we can't grow food here.
Right.
Here on Earth.
Exactly.
They aren't growing much on the International Space Station or in those nuclear submarines or at McMurdo Station in Antarctica.
Exactly. To circle back around to where I started with this is that I feel that the term global overheating would more accurately convey the dire situation that we're in rather than global warming.
I think that's probably right, yes. Whereas overheating is relatively simple and it's relatively new to the conversation. You say overheating, most people go, what is, I've heard of global warming, but what is this overheating thing? Yeah.
And you can warm up bread and it makes it real nice to eat, and you can change something and it makes it nicer to have it, but if you overheat something, you're headed towards a negative result.
Right, exactly. And so that overheating does have the implication of being overdone.
Yes, exactly.
Yeah, absolutely.
And I think, of course, there'll be resistance to that term, but that's, I think, the term that hopefully we can go forward with.
Yeah, I don't think there will be much resistance for long.
Not for long. Okay, well, let's explore that concept because you have said, you said in about 2016 that we have about 10 years and that there will be near-term extinction, human extinction, not just plant and animal extinction. And one of the things that I mentioned to you I would want to talk about is we're now at a position where we have 7.6 approximately billion people on the planet. And you are projecting a population of 0 at this point within 8 years.
Okay. Yes.
So I wanted to talk about how that line would work, how that would look. That line that starts at 7.6 billion and ends at 0 in 8 years. And my guess, first of all, would be that it's not going to be a line that goes out straight and then drops through the floor. Right.
Nor is it going to be a line that goes in linear function down to 0. Yeah. So you know, with an exact same number of people dying.
Right.
As opposed to being born every day. No.
So how would you say that line is going to look? And again, we're looking at a crystal ball. I understand it's hard to project things accurately depending upon human reaction, other types of things that can happen that maybe not even aware of now.
Right. And so, first of all, I am open to miracles. And I think that's what's absolutely necessary to get us through this particular predicament.
Right.
Is a whole series of miracles, in fact, to continue the run of humans. So what does that look like? I think it looks like business as usual until we can't anymore. I think it looks like more than 200,000 people added to the planet every single day. That's births minus deaths. Okay. Until we can't anymore. And when does that can't anymore show up? I think it comes as a result of an ice-free Arctic.
Okay.
With an ice-free Arctic, the amount of methane that will be released as a consequence of the ice-free Arctic, that ice cap keeping a lid on the methane, if you will, and also the lack of albedo or reflectance from the ice there that allows the blue ocean to just start absorbing that heat. If people are not familiar with latent heat, now's a good time to look it up.
Right.
So there's at least 12.5 self-reinforcing feedback loops in the Arctic alone.
Right.
So when the Arctic goes ice-free, I suspect very quickly thereafter we have no habitat for our species on Earth, anywhere on Earth.
Okay.
Shortly after that we have overheating accelerating to the point that we can no longer, for example, grow grains.
Right.
And once we can't grow grains at scale, then the whole set of living arrangements falls apart.
Yes.
The set of living arrangements we refer to as civilization, the ability to have food show up at the grocery stores and water come through the taps and fuel at the filling station. All that goes away if we don't have stored food in the form of grains at very large scale. So if you can't grow and store and distribute grains at scale, the set of living arrangements goes away in very short order. That probably happens within a matter of months after we have an ice-free Arctic. For example, if we have an ice-free Arctic in July, say, then that might so compromise the grain crop throughout the northern hemisphere, where almost all the grains are grown, that it causes the civilization to collapse later that year, September, say.
I see.
Or it might be the ice-free Arctic is delayed until September of that year. That's when there's typically the annual minima for the year in terms of ice cover in the Arctic. So if that happens in September, then I suspect the methane release and the heat absorption by a blue ocean means that the civilization doesn't collapse, that we aren't able to grow grains at large scale until the following growing season.
Okay.
So let's take, for example, if we have an ice-free Arctic this year, 2018, I suspect if that happens early enough in the year, say July, then probably around September, October, we have this event of collapse of civilization in short order. If, on the other hand, the ice-free Arctic is kind enough to wait until September, then that probably is not going to influence the ability to grow grains until the following year. The wheat crop in spring and the corn crop in summer, and so we're talking about getting another 8 or 10 months out of the deal. Well, a couple of things happen then. When civilization collapses, the people who depend upon water coming through the taps, which is most of the people, certainly most of the people we know, and who depend upon fuel at the filling stations and so on, they are suddenly facing a situation they've never faced before. Every other time the water stopped coming through the taps, every other time the lights went off, they came back on in a few hours or a few days. So I suspect there will be a lot of waiting for that to happen. And when it doesn't happen, people will die of dehydration and ultimately of starvation. And because of a phenomenon known as global dimming or the aerosol masking effect, once civilization is reduced or goes away, we have extra overheating that comes very quickly within 6 or 7 weeks of the demise of burning mostly coal.
I understand.
So then we see an additional exasperation. So maybe most of the people living in cities, which is more than 50% of the people on the planet right now, and something like 80% of the people in the United States. People living in cities depend upon that set of services that come in the city, including the water through the taps and the food at the grocery stores. When that goes away, I suspect we're going to see a very, very large die-off of human beings. But a few will evade that. A few will have off-grid places that they go to, like I built in New Mexico, for example, with 2 solar pumps and a hand pump and solar panels to keep the electricity on and so forth. But then, when we're no longer putting those sulfates into the atmosphere, then we're going to have a lack of global dimming, so the planet is going to heat up very rapidly within 6 or 7 months. And then those people who went to their bunkers, to their 1,000-acre properties in New Zealand or whatever, suddenly are going to find themselves unable to grow food themselves. Because that area is overheating just like every place else as a result of the collapse of civilization and the loss of the aerosol masking effect. So there's the first wave, then there's a second wave not long after that.
Now that's, you're describing a line that was sort of what I anticipated we might arrive at, and that is one that goes and then sort of does a chunk down. How deep that first drop is depends upon how worldwide the shortages are.
Right.
And then you have another sort of flattening out for a little while at that new level. Mm-hmm. And then you have another chunk down. Mm-hmm. And again, you have another flattening out probably at that newer level.
And then I think after that, I think then it's just a frittering away.
A frittering away, yes.
You know, so we have people who are in bunkers in a decent enough climate that they can continue to breathe the air.
Right.
It isn't the greatest dust bowl in the world,
right.
for which the Great Dust Bowl of the 1930s in the United States was just a warm-up act.
Right.
Right. So if you're living in a place that you're relatively protected from that kind of event, and you have a bunch of stored food, then maybe those people just start dying off in relatively slow numbers over time. And so you do get the first big dip, and then you get the second pretty good sized dip, and then I suspect after that it's just slowly withering away until finally, you know, the last person on the planet dies surrounded by the bodies of like-minded sociopaths when he eats the last can of peaches in the bunker. You know, I'd love to be wrong about all of this.
Yes, because this is,
you know, I'm not happy about my own death even.
Sure, because this actually, you're describing a shortening of your lifetime by a considerable amount.
Absolutely.
Yes, I mean, if someone is, you know, within the last couple years of their life, they may not see this as quite a tragedy for their life, but for everybody else on the planet, what you're describing is twofold. It's one, a loss or a shortening of their own life, and not a pleasant shortening. It's not a, okay, I'll end up, you know, going into hospice or whatever like that. It's going to be, when society collapses, that's not going to be a pretty sight.
No, it's absolutely not. And we have a few examples that have happened before, you know, the Soviet Union and Venezuela right now. And so social unrest that results when economic contraction becomes severe enough. We have a few examples. We've seen what happens also with previous civilizations.
And also,
and people, you know, people don't just go, well,
I guess that's it.
I guess that's it. See you later, Marge, or not.
No, they're well, we are also seeing with Syria, the movement of people out of that area. And there's going to be some of that happening as well, because as places become uninhabitable, people are not just going to, like you say, sit down and go, I guess that was it. They're going to drive to places that they hear are...
Especially people with children.
Exactly.
You know, if it's one thing to claim that I'm 58 years old and I had a good run and I'm not going to spend my final days as a refugee trying to find some place I can live comfortably, it's quite another for 28-year-old parents who have 3 young children.
Exactly.
That's a completely different kettle of fish.
One thing I put into my little script, you may have gotten far enough to see, there's a woman that starts to cry in class. Did you see that?
Yes.
That's actually based upon a friend of mine who has children. And I asked him, you know, about global warming and what his kids thought about it. And he said when he brings it up, his kids start to cry.
Yeah, you know, when I deliver presentations on college campuses, people cry.
I can imagine.
You know, 20-year-olds
because
facing this extremely uncertain and then horrific-looking future that they didn't hear anything about this.
No.
They heard that life always gets better for every future generation.
If it were just population that was not stressing resources, then there could be an argument that what would have eventually happened is just an adjustment of the population.
Absolutely, we'd have a profound die-off.
Yes,
and I read a paper, I think it was in The Guardian from 2 or 3 days ago, indicating that all we need to do is reduce by half the human population. And I'm thinking, volunteers, anybody?
Right.
Come on. You're not just going to get that. We're not going to vote on that.
Line form's over there, and I'm going this direction. Well, and that brings to another point I wanted to ask you about, because this is often not understood fully, that if we were today, and again I'm going to set up a hypothetical here, if we were today stop all further emissions of all greenhouse gases and not have the global dimming problem kick in, if all those wonderful things, none of which we expect to happen, if all of those things were to happen, the planet, my understanding is, the planet will continue to warm, and most of the effects that we are talking about are still going to happen. The Greenland is on its way to melting. It's not something, it's a freight train that no one is going to turn around. The Arctic will be free of summer ice and eventually possibly winter ice. I think Paul Beckwith is I guess, saying that it will also be free of winter ice, he predicts, within 10 or 15 years.
Oh, I think it'll be faster than that. They're far more accomplished and far more distinguished people than Paul Beckwith pointing out that there'll be an ice-free Arctic as year-round as early as 2023.
Okay. And
there's an esteemed Harvard professor who, what's his name? It escapes me right now. He's responsible for pointing out the effect of chlorofluorocarbons on ozone.
Yes.
You know, so this is somebody who's been studying atmospheric processes for a long time and has nailed it. And he says we don't have 5 years to turn this thing around before, if we don't rebuild the polar ice caps and deal with atmospheric phenomena. Right now, we're done.
Right. Yeah.
So
and the whole weight of society, the momentum of society, is so strong right now. And this is a conclusion I came to, and actually somewhat from reading not just your YouTube or viewing your YouTube presentations, but others as well. Had it been only your YouTube presentation, I would have been much more skeptical.
Of course.
But I went across the board at the many scientists, and while you were predicting things happening at a little earlier level, a little earlier time, you weren't predicting things that they said would not happen.
Right.
You were simply changing the timeline in which you thought things would happen.
Consider, for example, there's a 10-year lag in maximum heating associated with carbon dioxide emissions.
Right.
So the carbon dioxide that we're emitting today from running these lights and therefore operating the coal-fired power plant, the maximum heating from those carbon dioxide molecules will not be realized for another decade.
Yes.
That's locked in.
It's locked in, exactly.
So we're only now beginning to realize the full effects of carbon dioxide emitted in 2008.
Right.
In the last 10 years, we've burned more carbon dioxide than we burned in any previous 10-year period in the history of our run.
Right. So my feeling has been that given the knowledge that I have, I shouldn't say knowledge, but awareness, because I don't have any first-hand knowledge. My awareness comes from folks like yourself, that the only proper mindset that we should have would be something akin to, someone said, like a war footing, a state of emergency, and Bill Maher alluded to something along these lines, that if you are not alarmed, you do not understand what's going on. And if you're an alarmist, you are actually fully aware of all that is going on. And would you agree with? I mean,
absolutely. And yet I don't see that cry of emergency. I don't see that battle cry that we need to address this head on. Rather, I just see ignorance and have for a long time.
The more important things, though, are whether Trump is, involved with a former, what was it, playboy, prostitute, playboy, or,
did he have sex with a prostitute or did he not?
That's the important thing for us to figure out at this point. Michael Mann mentioned you in a video that's on YouTube, and he said that his objection to your prediction that we are pretty well toast in a fairly short amount of time, his objection was that it left us at the same position that the deniers leave us, of that of doing nothing. And I first want to confirm that that is not your advice to anybody, that we do nothing.
That's exactly right. That is not my advice.
No, I think you said what we need is, and you propose right action, I think, is what action and right action.
Yes, right action from a Buddhist perspective, taking what we believe are the right actions for the situation and not being attached to the outcome.
Right. Okay.
A couple of important points here about Michael Mann's ongoing statements that I'm somehow encouraging inaction. One, he doesn't disagree with me.
Exactly.
So that's telling.
Yes.
And two, he lies about what I propose.
Okay.
I've never proposed inaction.
Okay.
And three, I don't know what action he proposes. Civilization is the heat engine. Because of global dimming, if we turn off civilization, the planet heats even faster. So we're overheating the planet. Does he want to turn off civilization? I've never heard him recommend that, by the way, even though Tim Garrett's work is quite clear that civilization is a heat engine based on the laws of thermodynamics. I've never heard Michael Mann say we need to shut it off. What does he want us to do, given the paradox that civilization is overheating the planet, and turning off civilization overheats the planet even faster? So it's a little unclear what action he is proposing, and I try to be clear about the action I propose.
I understand. I think that, and again, I'm proposing this to you as a statement that you disagree or not, but I think that one thing that has been a problem is that scientists in general have filtered their statements. And scientists, I think, do that out of a natural cautionary approach to how they want to predict things, because their credibility would be very adversely affected when they make a prediction that turns out to be wrong, correct?
Absolutely.
And they have been filtering. Recently, and I say recently, within the last 3 to 5 months, there was a statement issued by 15,000 scientists. You're aware of that.
Yes.
And to me, that is one of the most alarming things that...
And another couple thousand have added their names since then. Actually, I think it's 4,500 have added their names since that came out a few months ago.
So I think that what is happening now is that scientists are finding themselves in the position of not wanting to, of course, be alarmist, but realizing that anything short of that is actually doing a disservice to the Earth, to the planet, to humans.
Absolutely. Self-censorship is commonplace in the sciences, and particularly in academia, where conservatism is preferred and is rewarded. And so, of course, people are censoring themselves. I worked with a guy who was doing his PhD dissertation on that very topic several years ago, somewhere in the northeastern United States, Massachusetts, I believe, and found that people admitted, that climate scientists admitted to self-censoring on a very regular basis. Of course they do.
And my feeling has been that the scientists have actually done their job to this point, in that they have raised the alarm to a sufficient level, and we have relatively ignored it as a civilization. And yes, they could have raised it a little bit better. Michael Mann actually has been the subject to attacks for the things he's...
Of course.
Yes.
As has Al Gore when he tried to popularize the message, and as you pointed out, Carl Sagan and Al Gore 33 years ago were pointing out the dire nature of the future that faces us. Where did that go? And didn't exactly make them rock stars.
And my understanding is, again, this is secondhand information, that the fossil fuel industry has a huge amount of money that they sink into disinformation. Well, I think disinformation is maybe the politest word for it. Because it's worse than that when you really get that. It's actually, when you get to the level that the result will be the dying off of billions of people, it becomes more than just disinformation.
Absolutely, and this is well known, and is the evidence is presented in many places, including the refereed journal literature now. So there is no question that the fossil fuel industries have benefited by covering up the evidence, just as the tobacco companies did not so long ago. And you know, it's BP, Shell, and ExxonMobil who are predicting a 5°C temperature rise in the very near future, and are wondering how we're going to mitigate for it. I'll tell you how we'll mitigate for it.
I know.
We're all going to die. That's how. It's not much of a mitigation.
What do you do? There is something too that, and talking with another scientist, a climate scientist, talking about the effects that you have a bell curve effect with some of these inputs. So a crop, as it gets more CO2, may do well to a certain point and then peak, but the drop off isn't a linear drop off as it encounters more heat. At some point, the drop off is it dies. And that's what I don't think people are quite aware of as well, that's what we're talking about. You have a potential for heat waves, and those will cause the drop off of that other side of the bell curve, and there's no recovery after that, at least no quick recovery.
40 degrees C, 104 degrees Fahrenheit is a number that everybody on planet Earth should have planted in their heads when they were in grade school. Because beyond that point, it's virtually impossible to grow food crops.
Yeah.
And that's at the soil surface.
Exactly.
It's 104 degrees. It's not that big a deal.
No.
You know, you live in New Mexico or Arizona, like I did for many years. It's that hot every day for months at a time. And you can't grow food crops at that temperature. And there are very few people on Earth who know what a big deal that number is. And that's a classic case of, it's not a bell curve, it's a profound falling off the cliff.
It's a steep bell curve on the other side.
Right, very steep.
Very steep on the other side. Your position is that we are in runaway right now. And that actually answers the other question I have, is you can't tell when you've hit runaway.
Exactly.
It's a threshold you cross, but there's no exterior...
There's no warning. And, you know, the United Nations Advisory Group on Greenhouse Gases in October of 1990 said 1 degree Celsius above the 1750 baseline is the absolute upper limit beyond which we could not cross without producing loss of habitat for other organisms, including humans. We will trigger a runaway effect.
Trigger a runaway effect, yes.
And that clearly happened at considerably less than 1 degree C, and now we're at least 1.6 C above the 1750 baseline.
Right. And we have locked in probably more than 2 degrees.
Absolutely. If we have even the minimal, the first paper in global dimming by James Hansen and colleagues indicates 1.2 plus or minus 2.2 degrees C as a result of global dimming. So if we turn off the switch of civilization, we're at 1.6 now minimum, and we add 1.2, that's 3.8. Okay. That's minimum.
Yes. And could you just, for a moment, for those that might not be quite sure what global dimming means and why it comes about, would you mind discussing that for a moment?
Most of us are familiar with the greenhouse effect. When we burn fossil fuels, we produce greenhouse gases, including water vapor, carbon dioxide, methane, chlorofluorocarbons, and so on. There's more than 40 of these greenhouse gases, and they trap heat. At the same time that we're burning those fossil fuels that produce greenhouse gases to trap heat, by burning some of those fossil fuels, we also produce aerosols or sulfates, most notably from burning poor quality coal. Poor quality coal means high in sulfur. Clean coal is low in sulfur. Most coal, the sort of conventional coal that's out there, is high enough in sulfur that when you burn it, it puts sulfates into the atmosphere. And those sulfates, the aerosols, produce an umbrella. So at the same time we're producing greenhouse gases that form a blanket that hold the heat down close to the surface of the Earth, we also produce an umbrella that reflects away the incoming solar radiation, the sunlight. So if we stop burning coal overnight, those aerosols fall out of the sky within 6 weeks or so.
I see. Very
rapidly. And so then we have a sudden, abrupt global average rise in temperature.
We lose that umbrella that's somewhat staving off some of the effects, somewhat mitigating the effects at this time.
Right. Yes. So we are producing umbrellas at the same time we're producing blankets. And when we remove the blankets, we remove the umbrellas even faster.
Right.
And so we close up all the umbrellas immediately, and within a few weeks, we're going to observe a very, very rapid global average temperature rise.
Yes.
And so at this point, you know, Michael Mann was featured in an interview with Tom Hartman this couple of years ago on RT, and he says, we can't stop burning coal. Wait, this is the leading paid climate scientist in the world, and he says, we can't stop burning coal, the dirtiest of the dirty fossil fuels. And the reason for that is that the aerosol masking effect, or global dimming.
Right. So unless we come up with something else in the way of an umbrella, maybe we can talk to the umbrella manufacturers and see if they can build something really big.
Exactly. And some people have proposed things like hydrogen bombs in the desert to put aerosols up into the atmosphere.
Right.
The very definition of bombing the planet to save it. People have proposed spraying seawater especially in the Arctic, up as high as we can. The very definition of using civilization to try to overcome a predicament created by civilization.
Yeah.
So, there are a few ideas that have been proposed to replace the aerosols when they start falling out of the sky.
Right.
I haven't seen anything approaching a consensus on that topic from a scientific perspective.
Right.
I think we're too far down this road with too little rope left to hang us, to mix my metaphors,
right?
to turn it back at this point and say, well, what we need to do is these four things.
Right.
I just don't see those four things emerging.
Right. Let's just take a moment and look at that, what's going on up there in the Arctic, because it actually is a bit complex, the different factors that are at play there. First of all, you have the loss of albedo, and that is the loss of reflective quality by having less ice. And then you, of course, in exposing the ocean underneath, you have now more absorption. So you've done two things there. Is that correct?
Yes, absolutely. And something important to keep in mind here, the difference between phase change and heating within a phase. So to convert ice to liquid water, so solid ice to liquid water at 0 degrees Celsius. So both at the same temperature, but it's just a phase change from solid to liquid. That requires, for a gram of ice, to convert it to a milliliter of water, requires 79.2 calories.
Okay.
That's a lot of heat. Now you take that milliliter of water, now that it's water, now it's melted ice, and you apply 79.2 calories to that.
Yes.
And it heats up to 79.2 degrees Celsius, which is scalding hot. So when we do that at the level of the ocean, a little ice goes a long way.
Yes.
So when we get rid of that last little bit of ice, then the heating is going to go very, very quickly.
Essentially, we'd be turning off an air conditioner to some degree.
Exactly, and people have pointed out that the Arctic is the planetary air conditioner, the Arctic ice, because it does cool the entire planet because of the general circulation patterns of the atmosphere.
And as the temperatures in the Arctic get higher, they get closer to, not close to, but closer to the temperatures in the meridian, near the equator.
Yes.
And that slows and affects both air currents, and I believe it affects ocean currents as well.
Yes,
is that true?
Absolutely. Ultimately, ocean currents, air currents, almost right away.
Right.
Yes. So, for example, the tangled jet stream, the polar vortex, the Rossby waves, it goes by a variety of names that we've observed over the course of the last few years, brilliantly pointed out and predicted by Jennifer Francis.
Yes.
And so the atmospheric phenomenon has been relatively well predicted, very well studied, and is responsible for the east coast of the United States, for example, getting really, really cold while the west coast is going into a drought. And so it's complicated enough that a congressman can go onto the floor of the Congress and start throwing snowballs and claim that global warming is a Chinese hoax or whatever. So and it is complicated.
I tried to explain this, maybe you can see if I've got this right, based upon what you're just describing there, is that the jet stream normally moved in sort of, shall we say, fairly small amplitude waves. And as the temperature differences between the Arctic and the equator became closer, the waves began to deepen, and that is one of the reasons why we're getting this effects on the East Coast, is now we have a deepening wave and it's going down further, and it's drawing the cold Arctic air down into a region where normally it would not have been allowed to go because you have this faster band of air.
Exactly. The amplitude is greater and the rapidity of the movement is slower.
Yes.
So the waves, the jet stream tends to get locked in place with these deep waves, and it just sits there.
And it sits there.
When we were kids, and I know everybody loves a story that starts like that. When we were kids, there was this thing called the Polar Express in northern Idaho, where I grew up. This cold front would go across the United States in the wintertime. It would take 3 or 4 days to cross the country.
Right.
And now we have these jet streams locked in place for months at a time.
Yeah.
They don't just boom, 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 and there's, you know, 1 or 2 of them a month, and they take 3 or 4 days, and it's just these cold waves that people expect, and the cold front is really cold, and clear sky behind them, and it's beautiful, but you can't even go outside because you freeze your fingers off. And now we have these things just locked into place for extended periods of time. It's a whole different system than it was before.
I wasn't fully aware, I appreciate you pointing that out, I wasn't fully aware of that other effect of slowing down the speed at which the jet stream is moving. That's, of course, as you're saying, that gets locked into place, so that's why the East Coast just gets hammered and hammered and hammered at these times. And it's particularly because of where it sits in relationship to the Arctic and the other effects going on.
And the drought, the long-lived drought in California, as a result of that just sitting there.
Sort of sitting there, yes. Yeah. So, and the slowing down of these things is negative in that we need winds, we need these currents to move, ocean currents. And as ocean currents slow down, other effects, which we're not sure exactly, but we have some idea what's going to happen.
Right. It's negative not just in terms of our convenience either.
Right.
It's negative because every species out there evolved through natural selection in light of a particular system.
Right.
And now we're changing the whole system.
Yes.
It's not the same system at the sort of large scale, the macro scale that it was 50 years ago.
Right.
And that's way too fast for species to evolve.
Exactly. And
even insects, that's only 50 generations.
Right.
So insects might be able to keep up with a little of that. Trees? No way.
Right.
Trees live hundreds of years.
Yeah.
You can't change a system in 50 years' time and expect trees to just say, well, I think I'll head north. You know, that's just not going to work.
Makes for a good horror movie, maybe. You know, The March of the Trees
March
north.
Of the Trees.
In April.
And if they get there, what are they going to have? They aren't going to have the same fungi. They aren't going to have the same mycorrhizae. They aren't going to have anything like they had before. The soils are completely different. So they get there and they're like, what do we do?
Exactly.
You know, it's like that movie, The Candidate. Going back a few years.
Back a few years. Robert Redford, right?
Robert Redford.
Okay,
so it's all about the candidate, and they have this great plan, and then they win the election.
And then what?
And they sit around at the end and they go,
now
the last line is, now what do we do?
Now what do we do?
There will be no humans to determine whether the planet goes lifeless or not.
Right, exactly.
It could be that we're only headed for 22 or 23 degrees Celsius, which is hothouse.
Yeah.
Right? That's the hottest the planet has been in the last 2 billion years, is 23 degrees Celsius global average temperature. It could be it'll stop there. It could be there are negative self-reinforcing feedback loops that halt the damage there, and then at some point, several million years from now, we have a thriving, vibrant planet again. That could be.
Yeah. I mean, one possibility that occurred to me, again, I'm not a scientist, so I haven't studied this at all. It just off the top of my head is like, well, if you melted both of the poles, you'd have a tremendous amount of water now that could absorb more heat. And maybe that would allow the planet to get through that period.
Right.
Too.
But a cause of considerable concern for me is those nuclear power plants that will be left unmanaged.
Yeah. I understand.
Okay. So there's no question at this point that the industrial economy, industrial civilization, whatever you want to call that, is causing the planet to heat up so fast that other organisms on which we depend for our survival are being killed. What that means for us is loss of habitat. So we cannot continue to foul our own nest, and that's basically what destroying habitat does. We can't destroy our ability to grow our own food and expect to survive.
Right.
And that's what we're doing. So global warming, climate change, overheating, whatever you want to call it, is as a result of industrial activity participated in by all of us, is destroying the home, the only home that we know about for us to survive, habitat.
And you predict extinction within 8 years.
Yes, I predict there will not be a human being on the planet in 2026. because of these so many factors we've set into motion that are destroying habitat for ourselves. It's not just that. It's not just global heating. It's also that we're in the midst of the sixth mass extinction on planet Earth. And every one of the previous 5 has destroyed almost all multicellular life, almost all complex life, and we're as complex as it gets in terms of our function, for millions of years. For millions of years.
Yeah.
So the people who think they can persist in bunkers, maybe for a few years beyond the loss of habitat, but then what? Millions of years for the planet to recover to a vibrant state again.
Yes.
That's a lot of canned peaches.
Yeah, living in bunkers is not a viable alternative to life as we know it.
No, absolutely not.
And the other aspect that occurred to me is that for people living in bunkers that have a nice supply of food, if they ever venture out, other people will see that they're doing pretty well. And if you have children, you're not going to let your children starve while somebody is off in a bunker. So if you can't stay awake 24/7, well armed against all type of assault, to me, having a small store of food is just a minimal solution.
And it brings up the Garrett Hardin question. Garrett Hardin, famous for his Tragedy of the Commons and living in a lifeboat. And his famous question was, and then what?
Yeah.
He said, this is the ecologically literate question.
Right.
The numerically literate question is how many?
Right.
The ecologically literate question is, and then what?
Yeah.
Okay, so you made it to your bunker.
Right.
So you've stored a bunch of food.
Yeah.
And I did that, by the way.
Yeah.
At the homestead I created in New Mexico, I have more than 5 tons, literally in a bunker, buried below ground, because I was going to live forever. I don't think that anymore. How naive of me. But even had I managed to ward off the neighbors or make friends with them, and we managed to recreate a set of living arrangements like we had 500 years ago, then what? Well, if we're in the dust bowl that never ends, that's still not going to help.
Right.
If we've lost all the food that we used to eat and the ability to grow that food, then as soon as my bunker's empty, I'm done. Well, when I started that project, we didn't know anything about global dimming.
Right.
You know, it was 2007. If you can believe it. The first paper on global dimming in the referee journal literature came out in December 2011 by Hansen and colleagues. And so up until I learned about the full effects of global dimming, I thought that if we could get some people through the bottleneck, then we would be able again to have the human species survive and carry on. Okay. So, but now I realize that we're in the midst of sixth mass extinction, as first reported in the referee journal literature in the summer of 2015 in the journal Science Advances. And this is a whole new ball game compared to where we were in 2007.
Right.
2007, I'm thinking Al Gore linear gradual style climate change, and we can adapt to that.
Right.
But this, because of global dimming and the many self-reinforcing feedback loops, those days are behind us. So we're done.
And you just mentioned something that I did want to touch on today, and that is, you've said this in your presentations, it's a concept that people really need to understand the urgency of our situation, and that is the exponential function.
You know, the world authority on the topic was a guy named Ed Bartlett, who was at Colorado University in Boulder. And he said probably 1,000 or more times in presentations around the planet, something like, I'm going to paraphrase here, but I think it's pretty close. The greatest failure of the human species is the inability to understand the exponential function. I would stop at the inability to understand, because we understand so little.
Right.
But certainly we don't understand the exponential function, because throughout our lives we basically never have to encounter it.
Right.
If we did, and here's a little thought experiment for you, if this happened to us when we were 10, say, and it happened to everybody when they were 10, and then again when we're 20, and maybe again when we're 30, just to remind us. I think then we would understand the exponential function and the ramifications it could have. So, say on a Monday you go to this grocery store, you need a loaf of bread, you go to the bread aisle, it's an aisle. You know, every big box grocery store in the United States, there's a bread aisle. Right. And it's comprised of bread. And there's one bread aisle. And so you go, you pick up your loaf of bread, you eat that, because you had a bunch of people come over unexpectedly. So Tuesday you go to the grocery store, and now there's 2 bread aisles. The amount of bread aisles has doubled in a day. And you don't think much of it. And you get another loaf of bread, but you did notice it. And then you come back a week later, and as a result of that doubling time, by the time you come back a week later, not only is that grocery store a bread store, but the next 3 stores are also bread stores. That's all they have. You're trying to pick up a gallon of milk. There's no milk, there's only bread.
Exactly.
That's the exponential function in a way that I think people can understand.
Right, that doubling effect.
But it never happens to us.
Right.
We don't see it, so we just blunder along through our day. The only place we see the exponential function that I'm aware of that's relatively simple to explain is in the case of non-indigenous species. So we get a new species that shows up, like the zebra mussel in the Great Lakes, for example, and it has no predators, it has nothing that's trying to kill it, so it just explodes until it fills the Great Lakes.
I see, yes.
And then it runs out of habitat. But it has a great run getting there. It goes like this. It goes exponential for a few years, and then it tapers off because it hits its limits. Everything else is about limits. And so we go through our daily lives and we hit limits all the time, and that's why we don't see the exponential function.
Right. Yeah, we often don't have to encounter it.
Right.
Even as we age, we generally age in an incremental manner, though there is some exponential. Yes.
You know, it's a sort of a gradual decline.
Yeah. And it's
mostly.
Yes. Going back to what we talked about as far as what's happening now, the amount of change is one factor, and it's an important factor because if you go up 3 or 4 degrees, that could be bad even if it were over a longer period of time. But the time period within which this is all happening is so great as to overwhelm any individual species' capability to evolve or adjust.
Absolutely. There's research, and I'm not going to be able to come up with the citation here, or even when it was done, but it was the early 2010s. And the paper looks at vertebrates specifically, and forecasts based upon the most extreme low heating scenario foreseen by the IPCC. And projects that even at that low, slow rate of heating from now to 2100, that rate of heating exceeds the ability of vertebrates to keep up by a factor of 10,000. We're 10,000 times too slow at the slowest rate foreseen by the International Panel on Climate Change, which is perhaps the most conservative scientific body on planet Earth. So if vertebrates can't keep up at the slow end, what's it going to look like at the fast end, which is what we're in now?
I did want to mention self-reinforcing feedback loop is what the term that you've used, and if you can just provide a quick explanation of that.
And some people call it a positive feedback, and I try to avoid that term because it's not positive for us. It's a self-reinforcing feedback loop. Self-reinforcing means that it takes on a life of its own. It's the snake swallowing its tail or whatever. And it's a feedback loop, so it feeds upon itself. So a good example is, say, a human being gathers up a big snowball and then rolls it down a hill. And to start the process off required the human being. But once the snowball starts rolling, it gets bigger and it goes faster, and the faster it goes, the more snow it picks up, and the bigger it gets, the faster it's able to go and knock down more things. You don't want to get in the way of it down at the bottom of the hill. It takes on a life of its own. And so that's a classic self-reinforcing feedback loop. And there are many of those. Consider, for example, the atmospheric moisture, water vapor in the upper troposphere, which is where most of the water vapor ends up. Every little bit of addition of water vapor in the upper troposphere acts as a lens. Water vapor is the most abundant greenhouse gas, more than 90% by volume.
Okay.
And so every 1 degree temperature increase, 1 degree Celsius temperature increase on planet Earth, increases the amount of water vapor in the upper troposphere by 7%. And every 7% increase increases the global average temperature by 1 degree. So it's a self-reinforcing feedback. The more we boil water off this planet by warming it up, the more we put water vapor into the upper troposphere, and therefore the faster the planet overheats.
It captures more, or retains more of that heat.
So it's a classic self-reinforcing feedback loop. The more you heat it, the more water vapor there is, therefore the more heating occurs.
I've heard the Arctic is warming at about 4 to 5 times at the rest of the planet. But I think the self-reinforcing feedback that occurs to me up there is that as it warms up and the ice retreats, it exposes more ocean to absorb more sunlight, which makes it harder for the ice to come back. Therefore, it retreats further, which exposes more ocean, which makes it harder even still for the, right? That's basically...
And the more the ocean opens up, the more the next storm is able to decimate the existing ice. So it all feeds upon itself. Every part of that is headed in the wrong direction.
Exactly.
There's no part of that gives me any hope that it's going to stop or turn around.
Right.
Yeah, because the less ice there is, the less ice there's going to be. And the less ice is going to be, the less ice there is, and it just keeps going.
Yeah. And some major reversal of conditions would have to take place.
Right. And, you know, I hear about shading the Arctic, for example. The geoengineers want to shade the Arctic. Okay. Well, it's been in the dark for the last 3 months. No shade needed. It's been in the dark. No sunlight has hit the Arctic for the last 3 months. Here we are on March 22nd, I think it is. And so it's been 3 months since there was any daylight, and the amount of ice did not increase.
Yeah, and why would that be? Is because...
At all.
And the reason is because the ocean beneath it has been warmed by the retreat of the sea ice.
Exactly.
Yeah, I understand.
And so there's more warm water underneath it than we know what to deal with.
Yeah, exactly.
And so just shading the Arctic at this point is not going to solve that particular self-reinforcing feedback.
We'd have to take care of the other effects that are involved.
It's a big, complex mess.
Yes.
And to think that we can just kick some particles up above the Arctic and cool it off is completely naive.
Yeah.
That is not going to fix anything.
No, that's not going to do it. Well,
it's almost as if we're fucked.
It's almost. And not in a good way.
I would like to live longer, personally, but from a scientific or rationalist perspective, I don't have an agenda here.
Right.
I'm not trying to cause the extinction of the human race, despite what you've read on the internet.
Well, I've never thought that.
Yeah, it's interesting because Michael Mann talked about the hockey stick. He wrote a whole book about it. Now he doesn't believe it. What is that?
Yeah.
Because it's inconvenient to believe it.
Yeah.
It's really an inconvenient truth.
Well, and it is a very inconvenient truth, but also there is the adjustment back to I want to have a normal life for the time period that I can.
Of course.
Without living in denial of the truth or...
You know, as a further example of the artists always get it first, there's a new series, an original series from Hulu. Most people think of Hulu as the organization that puts out other companies' episodes, right? But they actually have their own production team, apparently, and they're putting out a series called Black Sun. And the premise from the opening episode is that humans are extinct in 5 years.
Wow.
So they've got this.
Yeah.
So it's getting out there.
Yeah.
It's getting out there, eking into the public consciousness. I'd like to think, at least partially as a result of my work, and I think that's probably not too big a step. And I think that's a good thing. I think to remind people that their lives are short is not necessarily a terrible thing.
No, it isn't actually, to have that awareness that you want to savor every day. You probably remember John Wooden.
Oh, yeah.
And he said, one of his great sayings, he was a very, very good person. I actually once served him a hamburger. My claim to fame right there. But he
took
said,
years off his life with that cholesterol.
It probably did. He lived to like 95 though, so I think he's okay. If I took a few days away, I'm sorry. But he said, make every day your masterpiece. And it's a beautiful saying. It really is. And I find myself some days saying, wait, is this my, what, am I making this my masterpiece? Doing the best I can to enjoy and savor, because you never get a day back. Every day is spent and gone. So that's part of what people hopefully can take from this, is that if they have a great awareness, they can both move towards possibly solving things, but also planning their lives with...
to making their own days.
Yeah, to making their own days.
Sure.
Exactly. So,
that's wonderful.
Yeah. Well, thank you very much again.
Sure.
And I've enjoyed it.
Likewise.
Likewise.